There are two types of nuclear reaction that we need to know about in this topic. Nuclear fission, the splitting of a very large nucleus into smaller parts, and nuclear fusion, which is the coming together of small nuclei to form bigger ones. I've got an example of nuclear fusion on the board here. What you can see is a reaction that we call the proton-proton chain. Successive nuclear fusion reactions are gluing together protons and neutrons to form a larger element. It starts off with protons coming together and forming an isotope of hydrogen, deuterium, and that colliding with another proton to form another isotope of, in this case, helium, helium-3, which combines with another helium-3 to produce helium-4. Every single time there is a combining of these nuclei, energy is released about 6 times the amount of energy compared to nuclear fission. This is an enormously energy-rich situation. Every single one of these yellow flashes will give out an enormous amount of energy. Now, where does this happen? Well, this reaction happens inside of stars, including our sun. Deep down inside the sun, underneath the various zones, the core of the sun is under tremendous pressure from the weight of all the material acting downwards. Being crushed so tightly in means that those particles are constantly colliding with each other at very high speed because the temperature is in excess of 15 million degrees. Being so hot means that these atoms and these positive nuclei can smack together before their positive charges can stop them, giving off each time a colossal amount of energy that we enjoy down here in the form of sunlight. Where does nuclear fusion occur? The nearest place is in the centre of the sun, but you could also answer by saying in the centre of stars. This is the best and safest way to observe the sun. Pointing the telescope at the sun and having the light go through and be projected onto a wall. Better than having a mylar filter on the front because that can always fall off and there can always be holes in it. Also, by having it close to the wall, there's no temptation of a pupil to suddenly grab the telescope and look at the sun. But the sun is there, it is our nearest observable nuclear fusion going on. A second way of observing the sun's disk is by using a pair of binoculars. By covering over one of the lenses and pointing it at the sun whilst the other side points at a wall, you can get a really nice projected image. But with this you have to be careful because these are far more mobile and the pupil is far more likely to try to put them to their eyes whilst you're doing this activity. So you might want to consider putting it on a tripod to stop it from being picked up. Inside the centre of the sun, all of that ginormous weight of material pressing down on the core has the effect of increasing the pressure and the temperature down there into the millions of degrees. Under such extreme conditions, the hydrogen isotopes are smashing together so fast that the electrostatic repulsion that they have with each other hasn't got time to take effect, meaning that the nuclei of those elements themselves crash, collide and merge into heavier elements. This is what the sun is doing to release all of that energy that we here on Earth experience as light and heat. The process of merging those small nuclei together is forming the heavier elements. And that is really interesting because those heavier elements is what has formed us. But how have those heavy elements got out of the sun and into us? Well, the heavy elements that we are made from are not from our sun, but from stars that lived before. Stars that lived and died billions of years ago, that when exploded cast their remains across the galaxy, and that from that dust the nebula formed that formed our sun and planets. So the process of nuclear fusion is really important because it is what is actually responsible for driving the entire energy circus that we see here on Earth. that nuclear fusion reaction is incredible, because it's producing the light that is coming down here to the earth that these plants are absorbing. So through the process of photosynthesis, the energy that was released in that nuclear fusion is being captured and turned into sugars chemically that we and these animals are enjoying that when we eat. So life on Earth is utterly dependent on that nuclear fusion reaction.